Hi everyone. In this video we're going to do an introduction to some graphing ideas. So by the end of this you should be able to read and plot some coordinate pairs and graph any equation by making a table. So first let's start off with some of the key ideas, like what is an ordered pair? Okay, an ordered pair is another word for coordinate. It is just x comma y. Okay, so it's a coordinate in the form x comma y in parentheses, comma in between, where x is how you travel on the x-axis. Make sure you write this down. And y is how you travel on the y-axis, or how many units, I should say. All right, units traveled on y-axis. Okay, so that's what a coordinate is. Another word for that is an ordered pair. Okay, then I want to talk about what is a coordinate plane. So a coordinate plane is the actual graph that will look something like this, broken down into units like so. Okay, so that's a coordinate plane. In terms of structure of the coordinate plane, the horizontal axis going left and right is the x-axis. The vertical axis, which is going up and down, is the y-axis. In addition to that, the coordinate plane is broken down into 4 quadrants, 1, 2, 3, and 4. In the first quadrant, this is quadrant number 1, you're going to be positive on the x and y axis. This quadrant 1, you'd be positive numbers here, and you'd go positive numbers here. This is quadrant number 2. This is quadrant number 3. This is quadrant number 4. So it goes in that like circular direction. Okay, so in quadrant number 2, you'd be negative on the x-axis, but positive on the y-axis. In quadrant 3, you're going to move negative and negative again because you're going left and down. So this would be negative 1, negative 2. In quadrant 4, you're going to move positive on the x, but negative on the y. One more thing about the general structure of the coordinate plane. You have this very important point right here. Okay, this point 0, 0, where you don't move at all on the x or y axis, you're just kind of at the center, is called the origin. Okay, so the origin is often our starting point for some problems, so that's an important point to remember. So let's move on to actually practicing this, and we're going to plot and label some points on a coordinate plane. So first, I'm just going to sketch my axes. Again, this is my x-axis, this is my y-axis. Okay, you can sketch it the same way in your notes. Okay, then, I'm drawing this because I know you are at home. So we're going to sketch some tick marks to show 1, 2, 3, 4, 5, and 6. I'm going to do this on every part, every quadrant. Go up to 6 on yours as well. Cool. So we're going to plot and label the following points on the coordinate plane. Again, remember these coordinates are written in the form x first, then y. So that means you travel 6 on the x and 2 on the y, both in the positive direction. So you always start plotting at the origin, 0, 0, and move from there. So we'd move 6 on the x, 1, 2, 3, 4, 5, 6, and 2 on the y, up 2 because it's positive, to get our first point E, and label it because it says plot and label. Okay, now we're going to do T. So negative 3, negative 1. We start at the origin, but we're moving in the negative direction, x first, then y. So we'd move negative 3, then down 1 to get t. Okay, M, we move negative 2 on the x, then 4 on the y. 1, 2, then 4 on the y. 1, 2, 3, 4. So that would be M. By the way, I use ETM because those are my initials. Fun fact. Okay, so that's just a review of how you would plot points on the coordinate plane. The most important thing to remember is the point is written x first, then y, and that's the order in which you plot them. Move on the x, then move on the y. If you need to write a note of that, please do so on your notes. Otherwise, we are going to start graphing equations by making a table. So this is one method to graph equations, but as you learn more about math, there are other ways. This is a good starting point, though, because this is how you can graph any equation. Okay, so in order to make a table, you're going to need to have an equation like y equals x. And every equation has a rule, and this says whatever y is, it's exactly equal to x. So if y is like 2, well, x would be equal, so it would also be 2. If y is 0, well, then x would be 0. If y is negative 3, well, it's equal to x, so x is also negative 3. Okay, so the rule just says your y values and your x values are equal. It could even be like 100 and 100 if you wanted to be. Okay, but if you can make a table, this is another way to write a coordinate. So you have 2 in the x column, 2 in the y column. We can also write that as 2, 2. This can also be written as negative 3, negative 3. Okay, it's just a different representation. And then you can go ahead and plot these, and that's one way to graph an equation. We'll see what shape this is. So the first one, x is 2, so we're going 2 in the positive direction. Again, this is the x-axis, this is y. And on the y-axis, we're also moving 2, so we're going to go up 2 because it's positive 2, and that would be our first point. Our second point, 0, 0, again, that point is called the origin. And notice I picked any number I wanted to. I could keep going, and I could do like -10, -10, and on and on and on, but you only need a few points to graph the shape. You don't need to have infinitely many points because that would take you the rest of your life. But anyways, we're going to plot -3, -3. 1, 2, 3 is negative on the x. Negative on the y would be going down. So here's -3, -3. Realistically, I'm not going to plot 100 and 100, but you'd imagine it'd be like way up here. 100, then 100. You go left, or you go right, and then you go up. Okay. Once you plot your points, you can connect the dots and see what kind of shape this is. And remember, even though you only got 3 points drawn from your table, that doesn't mean the line stops. It would, in theory, go on forever, right? Like 4, 4 should also be a point. 5, 5, 6, 6. But we're only graphing a small sample, which is why I just extended the line and put arrows on. And this is one way to graph an equation by making a table. And this equation is special. It's like what we call a parent function for the line. Okay, so it's a parent function of a line, which just means it's the simplest line you can get. So it's y equals x. There's no like plus a number. There's no number in front of here. It's just the simplest one you can get, and that's called the parent function. Okay, so every line looks something like this, but then you can transform it by adding different numbers and multiplying different numbers. Just like this one here. A little bit more complicated because you have a -2 and a -1 here, but it's the same idea. Okay, we're going to plug in something for one of the variables and see what the other corresponding variable would be. Okay, so I'm actually going to plug in values for x, calculate it, and see what the y value is. One of the easiest numbers to work with is 0, so I'm going to plug in 0 first. Okay, so if I say x is 0 and I want to calculate what y is, well, I'm going to use my evaluating skills and plug in 0 for x and see what we get for y. So -2 times 0 is 0. That's why I pick 0, because it's really easy to multiply. 0 minus 1 is -1. So when x is 0, y is -1. Then I'm going to pick another easy number. I'm just going to pick, I don't know, +1 because it's easy to plug in. You can plug in anything you want. So I suggest you pick some numbers that you like. So -2 times 1 is -2 minus 1. So you take away one more dollar. Now you're $3 in debt. Okay, just to get a good picture of what the graph is going to look like, I'm also going to plug in a negative number. And I'll pick an easy negative number like -1. So you get y equals -2. Now x is -1 minus 1. Well, negative times negative is positive. So -2 times -1 is 2. 2 minus 1 is just 1. Ooh, the negative numbers seem to work out nicely there. So I'm going to plug in another negative number. And I'll say y equals -2 times 2 minus, times -2 minus 1. Negative times negative is positive, so that gives you 4 minus 1, which equals 3. Okay, now that I've made the table, and again, I picked any numbers I wanted. I just picked numbers that were like pretty nice and simple. I can plot them on the coordinate plane. So again, this is x, this is y. So 0, -1 can also be written like this. You're moving 0 on the x, so you're not moving left or right at all, but you move down 1. So that point would be right here, down 1. Our next point can also be written as x, y, 1, -3. So you're moving 1 on the x, so you move 1 this way, and down 3 on the y. Okay, so we'd be moving 1 on the x, down 3 on the y. Your next point would be right here. Next one, your x is -1, so we need to go x in the negative direction. So that would be -1, this would be +1. So we're moving -1 on the x, and up 1 on the y, +1. So that point would be right here. Then we have -2 on the x, so that'd be like right here, and +3 on the y. 1, 2, 3 would be somewhere like this. I'm freehanding this, so this isn't going to be perfectly straight. Sorry about that, because I didn't have a coordinate plane. I'm just sketching it. We're going to do our best to connect the dots, and it should look like a line that extends in both directions because you're only plotting a sampling of the x and y coordinates. You're not plotting every point on the line. Again, I could keep going, plug in more numbers, but this is a good enough picture. You only really need 2 points to plot a line. I'm going to have you make your own table and plot it on this next one. So pause the video, and I'm going to come back with the answer. No cheating. Okay, if done correctly, your line should look something like this. You may have picked slightly similar x values to plug in. Maybe you pick the same ones, but here's my work for them. Okay, so I picked 0 because 0 is easy to divide by 2. 0 divided by 2 is 0. And then you add 3 to it, so 0 should go with 3. Okay, then you'll notice I only picked even numbers, and that's because you have to take x and divide it by 2. And only even numbers can be divided by 2 without getting a fraction. So that's why I picked 2, and then I also picked -2 and -4. You could have also picked +4, and just to go through one with you, when you plug in +4, you're taking your x value, 4, dividing it by 2, and then adding 3. 4 divided by 2 is 2 plus 3 would be 5. And that should still be on the line. So here's 4, 1, 2, 3, 4, and here's 5 on the y. So as you can see, that point also lies on the line. I just didn't plot every single point on the line. I threw the arrows on there. Okay, so take a look at my work here, and if you have any questions, please let me know in the comments. Last point I wanted to make is that it doesn't have to be linear to be able to use this method. Okay, so no matter what x and y are, or what the equation looks like, you can plot using a table. Okay, so for example, let's say you have y equals 2 raised to the x, where x is an exponent. That's a little bit different. Okay, so let's say you plug in like 1 for x. Then you'd have y equals 2 raised to the first power, which is just 2. Okay, let's say you plug in 2, then you have y equals 2 with an exponent of 2, which remember an exponent is repeated multiplication. So this says you multiply 2 2 times, which gives you 4. Or you could do 3. That would be 2 raised to the third power, 2 to the exponent of 3, which means you multiply the base 3 times. 2 times 2 is 4, times 2 is 8. And just for a little fun tidbit, let's say you had 2 raised to the 0 power. You'll learn this later, but anything raised to the 0 power is 1. So don't worry too much about that right now, but if you do plug in your calculator, you'll get 1. Essentially, it's because exponent means growth, and 0 growth, well, that's like multiplying by 1. But anyways, it doesn't have to be linear to be able to plot using a table. I just made a table, and now I'm going to go ahead and plot them. So you need x's going from 1 to 3, so we have like 1, 2, 3. And then our y's need to go like 0 to +8, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Cool. So we're going to plot 1, 2. So again, that's like the point 1, 2. So we're going 1 on the x, 2 on the y. Then we have 2 on the x, 4 on the y, 3 on the x. We go all the way up to 8 on the y. Then we have 0 and 1. Okay, so that's definitely not completely linear. It looks curved here, which is fine. It doesn't have to be linear to make a table. An exponential graph will actually look something like this, where it like shoots up rapidly. Maybe you've seen some coronavirus graphs where, you know, we start slow and then we rapidly grow. That's because the growth rate of a virus is exponential. So anyways, we don't really need to know that right now, but what we do need to know is that you can use this table method on any equation, even if it's not linear, which is why this is such a useful skill. Okay, so hopefully you learned something new about ordered pairs, coordinate planes, and how to graph by creating a table. Take care.